Welcome to another video from explainingcomputers.com and to the first in a series in which I'm going to be building a budget PC using an AMD Ryzen processor. Specifically, in this video and the next one, I'm going to be selecting and assembling the components required to build a system with integrated graphics that will be capable of lower-end gaming and video editing, as well as many other computing applications. In part 3, I'll then turn to installing both the Windows and Linux operating systems and also testing out the machine's performance, and after that in part 4, I'll be fitting a graphics card upgrade. Finally, in part 5, I'll add some extra cooling and also a bit of RGB lighting so that our budget system not only works well but looks really cool. The price for the hardware with integrated graphics is going to be about £350 or about $380 for the same components purchased in the United States, and for that I'll be building a smart looking system with well-respected branded components. And once the graphics card is added, the price will go up to about £500 or about $610, although having said all this, across these videos I'll be giving you component alternatives. So if you want to build a similar build but using, say, higher specification components or different components, you'll have all information for that as well. Anyway, that's now got all the introductory stuff out of the way, so let's get on with the build. So, here we have our processor, which, as you can see, is an AMD Ryzen 3. And just in case you're not in the know, AMD is Intel's main rival in the PC and server processor marketplace, and in March 2017 launched its first Ryzen chips. And these were a great success and were followed by a second generation of Ryzen, including this processor in 2018, with a third generation of Ryzen processors expected to become available in the second half of 2019. Now, this particular chip is a Ryzen 3 2200G, and indeed if we spin the box around we can see it through a little window on the side of the packaging. The 2200G is a quad-core processor with a base clock speed of 3.5 GHz and a maximum turbo speed of 3.7 GHz. And the G indicates that this is an APU, or Accelerated Processing Unit, which contains both a CPU and a Graphics Processing Unit, or GPU. And specifically, the Ryzen 3 2200G has Radeon Vega 8 graphics, which means it's got 8 GPU cores. And this all means that we can use this chip to build a PC that will have reasonable graphics capabilities even without a graphics card. I purchased this chip in mid-January 2019 for £89, and at the time it cost about $99 in the United States. And this, I think, makes this an amazing value processor and a really great thing to use at the heart of our budget build. However, if you want to build a PC with a higher specification processor, you could substitute this with, for example, a Ryzen 5 2400G, which is also an APU, also has got integrated graphics, but which runs slightly faster and has 11 Vega graphics cores. Anyway, this is of course the chip I'm going to be using, so let's get inside. Let's bring in a Stanley with a knife here and open this thing up like that. There we are. And open it. Oh, there we are, look. It's always great to open up new stuff, and it tells you, look, it's the chip on top, and in here there'll be the chip, which we've already seen through the window on the side, and also the cooler. So let's take that out there, and how's it all packed? Here's the chip, which is, we'll have a look at that in a second. Nice to see there's a sticker to go with it for our case, and also here we've got, as I said, the cooler. Let's get this thing out. This is the Wraith cooler, which you get with all Ryzen processors. This is our stock cooler, which is again perfectly decent. Let's just open up the box, and here we are. Oh, it's exciting, isn't it? Come out, wherever you are. And here we are. Here is our missed bit of the packaging there, and that's important because this is our stock cooler. This will go on top of the chip to stop it overheating, but you'll notice on the base of here, this is our thermal compound. This provides the best possible junction interface, if you like, between the processor and the base of the heatsink. So we must be very careful not to damage this material. So I'm actually going to take the packaging and put it back on here. If I can get it the right way around, I think it goes in like this. There we are. That'll stop us damaging that. And so I'll put the cooler to one side. and we'll return our attention to the processor. And here it is sitting in its lovely piece of packaging. And I would say when you get your processor, you should leave it inside this protective packaging until the moment you wish to fit it in your motherboard. But I here am making a film. It is my job to show you things, and therefore I'm allowed to have a look inside before that moment. So let's just open this up, and there we are. And I'll just tip it out onto this static-free and very clean surface. We'll just turn it around like that, and we'll cut to an even closer shot to take a second to marvel at this extraordinary piece of modern design and engineering. I really do find the modern microprocessors amazing. They really are in many ways the pinnacle of our engineering and manufacturing achievement. And let's just flick it over to look at the back. Again, being very careful, and you can see all the pins here, 1,331 pins on the back of this processor, which will drop into the slot on the motherboard. And talking of the motherboard, I think it's now high time we went and had a look at that. Right, here I am back again with the most exciting unboxing of the build, which is that of the motherboard, which as you can see is a Gigabyte B450M gaming motherboard. And there's two features we should note here. Firstly, this is a socket AM4 motherboard, which means it'll take all current Ryzen processors. And secondly, it's got a B450 chipset. It's in the name of the board, it's written down here as well. And a chipset is the set of chips on a motherboard that control how the processor communicates with other components and interfaces, things like the memory, the PCIe slots, USB ports, SATA ports, things like that. And B450 was a chipset introduced with the Ryzen 2 processors, the second generation Ryzen processors, so it's the right one to use for the chip we're going to use. And AMD described B450 as a high performance chipset for anyone who basically doesn't want to build a PC with multiple graphics cards. If you want a really high-end Ryzen build, you should be using something like an X470 chipset, but B450 is fine for what we're doing here. So let's get inside this thing, and I think we have to flick it over first, and look, there's lots of exciting things to say on the back as well, but we'll leave those for now and open up with standing the knife. And you might want to note, because I'm handling a motherboard, I've got an anti-static strap on here. I'm grounded to a nice large piece of metal off screen, so I'm actually not going to be potentially damaging the board with a static. So anyway, let's flick it back the other way and open things up. And oh, there we are. And what have we got here? Various bits and pieces that seems to be attached. Oh, there we are. There's some SATA cables. So there's the I/O plate, the back plate, which will go into the case a bit later on. And other than that here, I can just get around that. How does it go? There we are. Get into the thing. And here's the board itself. Let's get this thing out. Anything else in the case whilst we're here? Oh yes, we've got installation guides, and we've got a driver's CD and or DVD and things like that. Let's get those out of the way over there and turn back to the motherboard itself. I do like new motherboards. This is the heart of computing, isn't it? Let's get in Mr. Scissors just to help us into the bag without destroying it too badly. There we are. And we can now take this thing out. There we are. Let's get it out like that and tuck into a slightly closer shot and indeed get things nicely lined on the screen there for you. Now, I should say in choosing this motherboard, I came down to a choice of three. And it was either this one, the Gigabyte B450M Gaming, but I also strongly considered the Gigabyte B450M DS3H and the MSI B450M PRO-M2, either of which would make great alternatives to this board. In terms of price, I paid £81.81 for this board, and at the time of making this video, you can purchase any of the boards I've mentioned here for somewhere between about £70 and £85 or $75 and $90. So let's have a look at the features of the board, and we'll start with this, which is the socket. This is a socket AM4 where our processor will plug in, and I should say this will take all current Ryzen chips, first and second generation Ryzens, but also a third generation Ryzen chip would also fit into this socket when they become available, but you would have to update the BIOS of the motherboard to use the third generation chip on the board, but you have got that upgrade capability. Below the processor slot, we find the ATX power connector and also 2 slots to take RAM. This board will take a DDR4 RAM, which is good. Got little levers here to flick it in and flick it back again. We'll be populating this a bit later in the video. And if we move to the end of the board, we've got all kinds of connectivity. For a start, we've got 4 SATA ports for connecting drives. We've also got an M.2 socket, which you can use to connect either a SATA or an NVMe SSD in this position here. We've got 3 PCIe 3.0 slots, 1 times 16 slots, which will take our graphics card. I love the red colours and a little shield, and that looks really cool. And we've got a couple of times 1 slots we could use for other cards potentially in the future. We won't be needing these in this build. We've also got here lots and lots of headers down the front, just to run you through what we've got. First, there is a system fan connector here, 1 of 2 on the board in addition to the CPU fan, so you can have 2 temperature controlled case fans in addition to the CPU fan. We've then got a header for a USB 3, 2 USB 3.1 ports will come off that and we connect them in. And then we have here the front panel connector, which is for everything you need to connect into the case itself, things like the power switch and the HD LED and that type of thing. Then moving along, there are pins so we can clear the CMOS if we need to reset things. There is a speaker connector and there's a couple of headers, each of which will give us 2 USB 2 ports. Finally, we've got headers for audio, both digital and analog audio. We've got a COM port if we need it, and we've also got a TPM port. TPM stands for Trusted Platform Module. This is if you need to add a device that requires hardware authentication. Most people won't need that, but it's there if required. Moving to the back panel, we've got a couple of PS2 ports for legacy keyboard and mouse connectors. Might be useful if you're trying to install, say, an older operating system. And also getting towards legacy of VGA port. It's nice to see that on the board. But beneath that, most people I think will connect a display direct to the board if they do, using the DVI port or the HDMI port. And so we've got 3 connectors for connecting a display if you're using onboard graphics, as we will be in the first stages of this build. Moving along, we've got 4 USB 3.1 ports. That's in addition to the 2 other USB 3.1 ports we've got a header for on the board. And then moving along from that, we've got a couple of USB 2 ports in addition to the 4 headers on the board. We've got our Gigabit Ethernet and we've got the usual analog audio connectors. Hiding in the middle of the board, we can find the second fan connector and also a connector labelled LED CPU. And this is for connecting RGB lighting either in the CPU fan or in the case. And we'll be using that connector to put some LED lighting into our system in the 5th video in this series. And then finally, all by itself on the other side of the board, we can find the 12 volt ATX 8-pin power connector. And so there we are, the Gigabyte B450M Gaming motherboard, a really beautiful piece of technology to form the basis of our new Ryzen PC. Now, before we start putting things together, I thought we'd take a look at our budget PC's memory. And as you can see, this is a Corsair Vengeance LPX RAM with this packet containing 8 GB of memory in 2 4GB DDR4 DIMMs. So let's open this thing up, and as you will see when we get inside, we just cut through there. What I've done, as you can probably see on the back there, I've actually purchased DIMMs which are with a red heat spreader so that they will match our motherboard. I can't get them out of the packet. Oh, there they are. Look, oh, they look exciting, don't they? Let's just get them out. Again, you should really leave them in here till you fit them, but because I'm making a film, I won't do that, although I can't get the... there we are, let's open the thing up. Let's take them out as well. Let's be really wild and put them on the table here. There's one of our DIMMs, and this is, of course, the other one. Aren't they really, really lovely? Let's just have a closer shot of those. And as I hope you'll agree, this RAM looks really good with its red aluminium heat spreaders. It's going to look really good in our motherboard with its red and black design, and we'll be able to see all this through the clear side on our case. Now, as you might have noticed from the packet, and I'll bring the packet back in, the speed of this RAM is 2400 MHz. And it's therefore worth noting that the motherboard we've got can support RAM modules with a speed of 2133, 2400, 2667 or 2933 MHz. So we could fit RAM with any of those speeds. But the faster the RAM, the more it will cost. And at the time of making this video, this Corsair Vengeance 8GB 2400 kit cost £59.99 or $62.99. But it is worth pointing out that RAM prices change very rapidly, they're always going up and down, so it's really worth shopping around to get the best speed and capacity of RAM for your budget. Finally, it's just worth noting if you want to know more about RAM and its specifications, you can look in my video which is called Explaining RAM. Right, it's now time to start fitting these parts together. And we're going to start with the processor, which needs to be fitted into the AM4 socket on the motherboard. And this is what's known as a ZIF, a zero insertion force socket, which means we don't have to force the processor in, rather we take this little lever and we just move it back like this, the whole thing slides back a bit and the processor will just drop gently into the socket. And to get it the right way round, you might be able to see this little triangle down here in this corner. This corner has one less pin than the others. We have to line that up with a triangle on processor. So if I get the processor and we just drop it in here, so drop in, no force at all required there, and you'll see the triangle has lined up that corner. Everything is absolutely fine there. We can now take the lever, put it back down again, and the processor will now be locked into place and installed in our motherboard. While the processor is now happily installed, it won't work for very long. It'll soon burn up unless we install the cooler, which has been waiting patiently over here and has still got its thermal compound on the base, which I've managed not to damage. And to install the cooler, what we need to do is to remove these brackets, because these have got bolts in them which go through to the other side of the board. And maybe if I turn the board over, you can see that. Let's just flick it over like this, and you'll see there's a back plate on the back which actually is what retains the cooler because the bolts go through from the front. So we'll remove the brackets and that will therefore take the screws out of here, and then we'll screw the cooler in. So its own bolts, its own screws will go through and hold it in place. So let's flick the board back the other way and take our screwdriver, and we can now take off these brackets. Let's just get these out here. Shouldn't take a second. And there they are, they have gone, and we can now take our cooler and very carefully, because we don't want to disturb that thermal compound, get it in just the right place and get it lined up there, there, there and there. That's sitting in the right place, and we can now just start to tighten down these screws. So you'll see they're sprung loaded, so they'll not go too tight. I think we'll do a few turns on that, and then we'll go around and do one over here. I think we'll do a bit on that one down there. Then we'll do a bit on the back, going around them. Oh, that was a good noise, wasn't it? Yes, it's definitely going down now. We'll go to this one here. I'll just continue around these. And there we are. They're all nice and tightly in place. And the final thing we need to do here is just to make sure we put in our fan connector. So this goes into the connector over there. So we'll just plug this in. And there we go. And for anybody thinking of building with this board, I just want to point out that there is very, very little clearance between this great big piece of metal on the back, which I imagine is some kind of heatsink, and the AMD stock cooler. As you'll see, if I just move it back and forth with my finger, there is some clearance. There isn't a problem here, but I couldn't have put this lug on this side because that would have stopped access to the RAM slots. We couldn't have fitted the RAM. This said, if you really don't want to have things like this, you could actually rotate the fan, not the whole cooler itself, because the cooler is on these rectangularly spaced screws, so you have to have a lug this side or this side, but the fan is connected by 4 screws here, here, here and here, and these are in a square, so you could take these screws out, take the fan, rotate it 90 degrees, put it back, and that would work. This said, I'm perfectly happy with the way things are. Things are functionally absolutely fine, so I'm going to leave things as they are. Guess what? Here I am back again with our lovely motherboard, which we're building up into our Ryzen PC, and over here our RAM is waiting to be fitted, so let's grant it its wish. And all we need to do is to open up little tabs here on the side which secure the RAM in place, and then we can now take each module and drop it in like this. One will go in like that's secured in there, and the second one will go in front of that and secure again in a similar fashion. And there we are, we've got our 8GB of RAM installed in our motherboard. Everything is looking rather nice, I think, so I think this is a good point to leave the build for today. In this video, I've put together the guts, the core components of our new Ryzen PC. This said, fairly obviously things are far from finished, and so in my next video I'll be adding a case and a power supply and an SSD so we have a fully completed working PC. More information on this build can be found on explainingcomputers.com. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.